If you were put in charge of building a massive suspension bridge, your very first step wouldn't be to just like hand out some steel cables to a construction crew.
Right, just pointing to the river and saying, hey, figure it out as you go.
Exactly. You would need blueprints, you would
Hmm.
need exact, down to the millimeter measurements, rigid timelines, and, a highly sequential plan.
Yeah, Phase B absolutely cannot start until Phase A is locked in concrete. It requires absolute predictive certainty.
Right.
You build the foundation, then the towers, then you string the cables. The environment is static, the physics are known, and the process is strictly linear.
But then imagine you are launching a tech startup or, you're organizing a massive multi-day industry conference.
Totally different beast.
Yeah, if you try to use that same rigid bridge building mindset, you are going to crash and burn the second a keynote speaker cancels. Or the moment your beta users decide they actually hate the app feature you just spent 6 months building.
Because that expensive blueprint you created just becomes obsolete almost instantly.
And that exact tension between the certainty of building a bridge and the chaos of launching a startup is why we're doing this deep dive today. We have a really fascinating stack of sources for you.
We do. We're looking at insights from a comprehensive industry survey on agile frameworks, plus some highly detailed real-world case studies.
Yeah, and transcripts featuring project leaders from NASA, the financial sector, and applied AI.
Right. And our mission here is to decode the mechanics of adaptive project management.
Which is such a buzzword. I mean,
It is. But the goal is to extract the actual core nuggets of how you can get things done efficiently in a world where the plan always changes. Turning uncertainty from a project killer into a competitive advantage.
and to really understand how to wield this flexibility, we first need to look at the fundamental mindset shift that has to occur. Like before a single task is ever assigned to a team member.
Because adaptive management isn't just a new calendar of meetings or a new software tool. It's a completely different philosophy about failure, planning, and value.
Yeah, and the sources use this remarkably simple analogy for this. They argue that predictive planning the bridge building is like baking a cake.
Which is a great way to think about it. You have to follow the recipe exactly, measure
Yeah.
the flour perfectly, bake it at a specific temperature for a specific time.
And you get a guaranteed predetermined outcome.
Right. But adaptive planning, that is like cooking a stir fry.
A stir fry.
Yeah, with a stir fry, the process is dynamic. You taste it as you go. You realize it needs more soy sauce. Or you notice the broccoli is cooking way faster than the carrots.
So you adjust the heat on the fly.
Exactly. You're reacting to real-time feedback and adjusting based on the ingredients you have available in that exact moment.
But okay, let's unpack this. Because surely there are limits to the stir fry method.
What do you mean?
Well, I was looking through our sources at this interview with Tammy Ashraf. She's an Earth Science Systems Integration Manager at NASA's Goddard Space Flight Center.
Oh, right.
And NASA is like the ultimate high-stakes, zero margin for error environment. You can't exactly fail fast and iterate on a stir fry when you're launching a billion-dollar rocket with human beings strapped to it.
No, you definitely cannot. The aerospace industry is understandably risk-averse.
Yeah.
I mean, you cannot patch a physical O-ring once it is in orbit.
Exactly.
But Ashraf points out something highly revealing about modern systems engineering. Even NASA is embedding agile methods into their traditional rigid frameworks to accelerate innovation.
Wait, really? How?
Well, they don't use agile to test the physical rocket propulsion, but they absolutely use it for the complex software systems that drive those hardware functions.
Oh, because software can be iterated.
Right. It can be tested in small batches and adjusted based on feedback. And Ashraf emphasizes that the true change agent for her teams isn't just dropping a new project management software onto a team.
It's the mindset.
Exactly.
Yeah.
Getting brilliant engineers to adopt the agile mindset, getting them comfortable with the idea that the first iteration of the software won't be the final one.
Okay, but if this agile mindset is so incredibly flexible and everything is a constantly changing stir fry of software updates, how do you avoid total chaos?
That's the big question.
Right. Like if you don't have a rigid blueprint mapping out the entire year, how do you ensure the team actually ships a working product and stays within a budget?
Well, what's fascinating here is that the flexibility of agile is completely misunderstood by people who think it just means doing whatever you want.
Right.
The flexibility is actually held together by highly disciplined, highly specific structural frameworks.
So it's not just a free-for-all.
Not at all.
Yeah.
And utilizing those frameworks requires a shift in how an organization defines success. Traditional value engineering focuses on delivering a specific list of deliverables on time.
Like, did we build the bridge by Tuesday?
Right. But outcome-based adaptive management focuses on achieving actual business impact. The goal isn't just to finish building a software tool by Friday.
Right. The goal is to ensure that the software tool actually improves efficiency for the end user, even if the final version looks entirely different from what was pitched in the kickoff meeting.
Exactly.
So, to avoid that chaos, we need to look at the toolkit. We need to look at the concrete structural frameworks that keep these adaptive projects on the rails.
And looking at the sources, there isn't just one universal way to do Agile. Teams have to choose a framework that actually fits the way their specific brains work.
So, let's look at why a team might choose one over the other, starting with Scrum, which is arguably the most common, right?
Oh, definitely. Scrum relies on strict time boxes called sprints, usually lasting between 1 to 4 weeks.
And the mechanics here are designed to force focus, aren't they?
Yeah. At the start of the sprint, the team commits to a specific chunk of work. Every single day, they hold a short coordination meeting, the daily scrum, to flag hurdles.
And crucially, at the end of the sprint, they hold a retrospective.
Right, to explicitly discuss what went wrong and how to improve the process itself for the next sprint. It requires a dedicated cross-functional team that isn't being pulled into outside projects.
But what if your work doesn't fit neatly into a 2-week box? Like an IT help desk where you just get an endless stream of random tickets.
That is exactly where Kanban comes in. Kanban ditches the fixed sprints entirely. It's flow-based and highly visual.
You map out the workflow on a board with columns like to do, in progress, in review, and done.
Yeah, but the core mechanism, the thing that makes Kanban actually work, is limiting your work in progress, or your WIP.
That WIP limit is where the discipline comes in, right?
Yes. In Kanban, you use a pull system. A developer cannot start a new task. They cannot pull a new ticket into the in progress column unless the team actually has the capacity for it.
So if the WIP limit is 5, and there are 5 items in progress, nobody starts anything new until one of those items moves to done.
Exactly. It forces teams to finish what they start, rather than context switching across 20 half-finished tasks.
Okay, let me see if I can map the difference between those two with an analogy.
Go for it.
If Scrum is like a highly structured relay race where batons are passed at specific predetermined intervals,
Okay.
then Kanban is more like a continuous water slide. The main goal of Kanban is just to prevent a massive traffic jam of people at the bottom.
I love that.
Yeah.
And keeping that water slide clear requires strict rules about how many people are allowed on the slide at the same time.
Right. Now, beyond Scrum and Kanban, the sources detail specialized frameworks for different environments, too.
Yeah, you have Lean, which approaches project management purely through the lens of minimizing waste.
And in knowledge work, waste isn't leftover steel cables. Waste is unnecessary meetings, redundant approval layers, or overproduction.
Like spending 3 months building a complex dashboard feature that analytics show absolutely no one ever clicks on.
Oof, yeah. The sources also detail extreme programming, or XP.
Right, which is highly technical.
Yeah, specifically for software development, it enforces practices like pair programming, where 2 developers literally sit at one workstation and share one keyboard and monitor.
Which sounds intense.
It does, but the logic is that 2 brains actively reviewing every line of code as it's written drastically reduces bugs down the line.
It embraces changing requirements by relying on incredibly high-quality, heavily tested engineering practices.
And finally, for massive enterprises that need to synchronize thousands of people, there is SAFe, the Scaled Agile Framework.
Because you can't just have 50 independent Scrum teams running in different directions. SAFe organizes multiple Agile teams, usually groups of 5 to 10, into what they call Agile release trains.
That sounds like a lot of coordination.
It is. It provides a cadence so that all those separate teams are integrating their work and releasing it on the same unified schedule, keeping massive corporate initiatives aligned.
But whether you are running a 2-person pair programming team or a massive Agile release train, you need a master list of exactly what needs to be built.
Yes, you do.
And that brings us to the engine that drives all of these frameworks, the product backlog. If Kanban is the continuous flow and Scrum is the sprint, the product backlog dictates what flows and what we are sprinting toward.
It is the single source of truth for a project, a prioritized, constantly evolving list of features, fixes, and requirements.
But a massive list can easily devolve into a chaotic wish list if it isn't managed.
Oh, absolutely. That's why Tony Johnson, a project management expert in our sources, uses the acronym DEEP to describe a well-refined backlog.
Okay, so the D stands for detailed appropriately,
Right.
meaning the items at the very top of the list, the tasks the team is pulling tomorrow, need to have highly specific granular instructions. But the items at the very bottom, the stuff we might do 6 months from now, can just be vague ideas.
Exactly. You don't waste time writing detailed specs for something that might change next month.
Makes sense.
Then the first E is estimated, meaning the team has assigned a rough idea of the effort required for each task so they know what they can actually fit into a sprint.
I'm going to guess the second E is emergent. Like the stir fry, it's a living document. It changes as market conditions change or as the team learns new things about the product.
Yeah, it's never locked. And finally, the P is prioritized. This is the absolute core of the backlog. Items are strictly ranked.
But how you rank them is where the real strategy lies.
It really is. Denise Steer's research points out several prioritization methods. One is the Kano model, which forces you to balance must-have features with delighter features.
So, like, if you're building a car, a steering wheel is a must-have. Heated seats are a delighter.
Right. You have to build the steering wheel first, but you need a few delighters to stay competitive.
Another method she highlights is calculating the cost of delay. Instead of asking how much will it cost to build this feature, you ask, how much revenue or market share do we actively lose every single week we delay shipping this feature?
And this prioritization isn't just an academic exercise. There's a wild, real-world example from Falguni Rollikar in our sources that shows how this actually works under pressure.
Oh, yeah. Rollikar was leading an agile project to launch a new healthcare insurance policy.
Right, so they have their backlog, they're executing perfectly, and they are right in the middle of their fourth sprint.
The developers are head down, actively working on building out the complex reporting features for the software.
And then the client's market research team drops a total bomb.
Yeah, they suddenly realize that to be competitive in the current landscape, this new insurance policy absolutely must include coverage for a major new medical condition.
Mid-sprint. The client demands this massive new requirement be added to the scope of the project.
Now, in a traditional predictive waterfall project, this is a crisis. Contracts are broken, change requests are filed, timelines are shattered, and lawyers probably get involved.
Oh, for sure. But because they used an adaptive framework, they didn't panic. They paused.
They analyze the business value using that cost of delay mindset.
Exactly. The client realized that launching without this new condition would render the policy obsolete on arrival. It was a crucial market differentiator.
So the Agile team simply looked at their current sprint. They took the reporting features they were currently building, put them on hold, and placed them back into the product backlog for a future wave.
And they instantly pivoted their immediate focus to the new condition.
But, let's look at the human element of that. Doesn't constantly dropping everything for a new feature absolutely destroy team morale?
It can be tough.
Like, a developer just spent a week writing code for a reporting engine, and you tell them to drop it and start over on something else. Doesn't that ruin the original budget and schedule?
Well, it requires a massive shift in expectations for the developers, yes. But if we connect this to the bigger picture, the ultimate goal of adaptive management isn't sticking strictly to the original schedule you guessed at 6 months ago.
Right.
The goal is return on investment. The goal is delivering the highest possible value to the customer right now.
So putting a lower value reporting tool on hold to capture massive market value with a new condition is a feature of Agile, not a bug.
Yes, exactly. However, the risk of developer burnout is very real. To ensure the team isn't actually just spinning their wheels and failing under the weight of constantly changing priorities, a project manager has to measure the team's speed and their roadblocks obsessively.
Which brings us to measuring the unseen. The pivot to a new insurance feature is only going to be successful if the team can actually deliver it without breaking down.
And Agile teams track this using specific, highly revealing metrics. The two most critical ones in the sources are lead time and cycle time.
And the distinction between those two dictates how you diagnose a failing project, right?
Yes. Lead time is the total elapsed time from the exact moment a customer requests a feature or reports a bug until that feature is completed, tested, and delivered to their hands.
Okay. And cycle time?
Cycle time is a subset of that. Cycle time only measures the time from when the development team actually starts working on the task to when it is completed.
Let's try another analogy. Think of it like ordering delivery.
Okay, I'm listening.
Lead time is from the moment I place a pizza order on an app to the moment the delivery driver hands me the box at my front door.
Okay.
Cycle time is just the actual time the chef in the kitchen spends tossing the dough, adding the cheese, and baking the pizza.
I love that analogy.
As a customer, I don't care about the kitchen mechanics. I only care about lead time. I want my pizza fast. But the kitchen manager must optimize the cycle time to make that happen.
Right.
If the lead time is 2 hours, the manager needs to know if the chef is taking too long to bake it or if the pizza is just sitting on a counter waiting for a driver.
That perfectly illustrates why measuring both is essential.
Mm,
And to optimize that kitchen, or that software team managers use a cumulative flow diagram, or a CFD.
a CFD.
Yeah, it's a visual chart that tracks work items through the different stages of your Kanban or Scrum board over time. The x-axis is time, and the y-axis is the number of tasks.
And the different stages to do, in progress, testing, done, are represented by colored bands. Reading these diagrams is like reading the tea leaves of project management. The visual patterns reveal the hidden truth of the team's workflow that a daily status update might miss.
Yeah, if you see a sudden, steep vertical slope on the graph, it means an overwhelming volume of work just got dumped into a specific phase.
And if you see entirely flat periods, it means work has completely stagnated. But the most dangerous sign to look for is a widening in-progress band.
Definitely. A widening in-progress band means tasks are entering that phase, but they aren't leaving it. It reveals a major bottleneck.
And our sources include a great case study about this with a team-building CRM software.
Oh, right. They were on a tight deadline, working hard, but no features were getting finished.
So they pulled up their CFD and noticed their in-progress band was getting wider and wider every single day. This visual data alerted them that developers were accumulating tasks but getting stuck.
So they did a root cause analysis. They didn't just yell at the developers to code faster.
Good management right there.
Yeah, they dug in and realized two things. First, they had a severe lack of resources in the testing phase, so finished code was just sitting there.
Like the pizza on the counter.
Exactly. Second, the task definitions in the backlog were incredibly unclear. Developers would pull a task, get confused, put it aside, and pull a new task to try and stay productive.
It was a context-switching nightmare.
Total nightmare. So by using the visual data of the CFD, they stopped pulling new work. They swarmed the bottleneck.
They reallocated resources to help with testing and spent time clarifying the upcoming tasks.
And almost immediately, they shrank that in-progress band, drastically sped up their overall delivery, and improved the quality of the software because developers were finally able to focus on one thing at a time.
Wow. Teams also pair this with burn-down charts, right?
Yes. Burn-down charts visually plot the amount of work remaining against the planned effort for a sprint, so you know by day 3 if you're going to miss your deadline on day 14.
It takes the guesswork out of management. But, we have to transition here from perfect theory to messy reality.
Yeah, we do.
We've discussed how Agile works beautifully in a vacuum, with perfect metrics, dedicated teams, and clear backlogs. But how does this adaptive mindset survive in environments that aren't naturally suited for it? Because not every company is a nimble tech startup running on Slack.
Organizational fit is the biggest variable in whether an adaptive framework succeeds or fails. Agile is a brilliant fit for virtual, remote teams with modern communication tools.
And it's ideal for co-located teams who can do face-to-face daily stand-up.
Right. But if you try to force an Agile framework into a deeply hierarchical organization where every decision requires 4 levels of executive sign-off,
Or a complex matrix organization where developers are split across 6 different projects.
the framework shatters.
Dora Magia, a technology consultant operating in the highly regulated financial services sector, provides some incredible insight into this reality.
She uses 4 distinct variables to determine if an adaptive method is actually the right choice for a project. Right.
Yeah. Product attributes, the organization's actual experience with Agile, the change management implications, and procurement or vendor readiness.
And her real-world examples contrast this perfectly. She was leading a massive project to roll out a brand new software system across an 800-branch bank.
Because software can be segmented, they used an adaptive incremental MVP approach.
Right. They rolled the software out to just a few branches first. They monitored the bugs, learned how the tellers actually use the system, adapted the code, and then rolled it out to the next batch. It was highly successful.
She had another project where she had to physically move a bank's data center to an entirely new geographic location.
Oh, yeah.
For that project, she required a rigid, predictive waterfall approach. I mean, you simply cannot move 10% of a massive server rack to a new building, turn it on, and see how it goes.
It's binary.
Exactly. The servers are either moved and functioning, or the bank is offline.
The risks and the absolute lack of value in making small increments made Predictive the only logical choice there. And we see this messy reality play out in smaller organizations as well.
Definitely.
There is a fascinating perspective, and the source is from a lone project manager working at a small nonprofit. They don't have a massive IT team or dedicated scrum masters.
They face sudden funding losses, high staff turnover, and a board of directors with constantly shifting priorities.
Right.
Okay, here's where it gets really interesting. Because for that nonprofit project manager to survive, their tactic is to adapt the agile framework itself.
Wow.
They keep the rigid Gantt charts updated because the nervous board of directors needs that visual structural anchor to feel safe.
But internally,
Internally, they purposefully ditch the heavy, formal stakeholder analyses and run their small team on a Kanban board just to save their own mental bandwidth.
that's brilliant. To successfully use an adaptive framework, you literally have to adapt the framework itself to fit your company's messy reality. Right. There is no perfect one-size-fits-all template.
Which brings us to what project management professionals call enterprise environmental factors, or EEFs.
This raises an important question. Before a leader decides to force Scrum or Kanban onto a team, they have to deeply assess their company culture, their market conditions, and their actual leadership support.
Yeah, Adenka Adeniran, a technical program manager at Quantify, reinforces this beautifully in his interview. He notes that for an organization to truly maintain a competitive edge, Agile cannot just be an isolated software development process running in the IT basement.
No, it must be a culture embraced by the entire company.
Because if the IT team is running 2-week sprints, but the supply chain procurement team takes 6 months to approve a software license, your Agile process is dead on arrival.
Exactly. From logistics all the way up to the senior executives making the ultimate financial decisions, everyone must be aligned on delivering value continuously, rather than just checking off project milestones.
It requires moving away from a project mentality where the goal is just finishing tasks and moving toward a product mentality.
Right, where the team is relentlessly focused on the long-term outcome and the actual value being delivered to the end user.
So, bringing this all together for you listening right now, whether you are writing lines of code for a tech startup, whether you are organizing a massive, chaotic industry conference, or navigating the unpredictable funding of a small nonprofit.
The ability to prioritize dynamically and visualize your bottlenecks is your superpower.
It's about knowing when you need to build the rigid blueprint for the suspension bridge and when you need to start tasting the stir fry and adjusting the heat on the fly.
It's about utilizing the structure of the backlog to navigate the chaos of the environment.
So what does this all mean for the future of how we work? Adenka Adeniran mentioned how teams are already starting to leverage artificial intelligence and machine learning to make more data-driven project decisions.
Yeah, that's where it gets wild.
If the absolute core of Agile is responding continuously to feedback and adapting to change what happens when artificial intelligence begins processing global market data and live customer feedback in real time,
Will an AI eventually be able to instantly rewrite and reprioritize our product backlogs overnight while we sleep?
right. In the near future, the most valuable skill might not be managing the sprint or tracking the cycle time.
No.
The most valuable skill might simply be looking at the backlog the AI generated for you that morning and deciding if the machine has pointed us in the right direction before we start cooking the stir fry. Something to think about. Imagine taking 16 years to, deliver a single project to a client.
I mean, that is a wildly long time.
Right. 16 years of missed deadlines, changing materials, and likely some very, very frustrated patrons.
Oh, absolutely.
And that is exactly what Leonardo da Vinci did with the Mona Lisa. When we think of projects, we usually picture massive construction sites, right? Or like a team of software developers in a room full of whiteboards.
Yeah, or just a lot of corporate red tape.
Exactly, corporate red tape. But today, we're going to explore how that modern corporate red tape, the kind we all love to hate, might have actually saved Da Vinci, and more importantly, how it can tame the chaos in your own life.
You really can.
Welcome to the Deep Dive. We have a fascinating stack of sources today covering predictive, plan-based methodologies. Our mission here is to decode how this highly structured approach works, when you should be using it, and, well, why it is so much more than just corporate jargon.
Yeah, because it actually functions as this incredibly powerful framework for navigating complexity. But to truly grasp how it manages that complexity on a global scale, we kind of need to strip away all the corporate speak.
Right, get back to basics.
Exactly. We need to start with something almost absurdly simple. The sources provide us with the ultimate baseline analogy for a predictive project.
Okay, let's unpack this. The analogy they use is boiling an egg, which, I mean, sounds ridiculous at first.
That sounded big silly.
But when you look at the mechanics, it is entirely predictive. You have a clear, highly stable requirement. You want a hard-boiled egg. The outcome is completely known before you even turn on the stove.
Yes, there are no surprises there.
And the tasks are strictly sequential. Like, you cannot strain the water before you boil it. You fill the pot, add the egg, boil for 10 minutes, remove, strain, and then peel.
The sequential nature is the whole key here, and it maps flawlessly to the core mechanics of a predictive approach. In this methodology, you operate within a concept known as the predictive triangle.
The predictive triangle, right.
Yeah, so in this triangle, your scope, which is the actual physical work required to deliver that boiled egg, is permanently locked.
Meaning I can't just change my mind.
Exactly. You don't get halfway through the 10 minutes of boiling and suddenly decide you want toast instead. The scope is fixed. However, the cost, the quality, and the schedule are your variables.
Okay, so if I suddenly realize like a bunch of guests coming over and I want to boil 50 eggs instead of 2, my core scope remains exactly the same.
Right. The act of boiling eggs.
But my cost just went up because I need to buy more eggs, and my schedule is probably going to change because I have to dig out a massive catering pot or, boil them in 5 separate batches.
That is the perfect way to visualize it. You manipulate the variables to serve the fixed scope. Now, if we take that underlying logic and scale it up from breakfast to a massive real-world scenario from our sources, picture this. You are the implementation manager tasked with rolling out an enhanced software reservation system across more than 2,000 hotels globally.
Oh, wow. 2,000 hotels. Across different time zones, different languages, different staff sizes. I mean, that is a colossal leap from a saucepan.
It is massive in scale, yeah.
Yeah.
But the fundamental logic remains identical to the egg. You have a known outcome.
Right.
You need this reservation system to go live so that, say, a customer in Tokyo can pick a specific twin bed on the 7th floor with a skyline view. Because that end state is known, you perform detailed planning up front.
So you're not just figuring it out as you go?
Not at all. You identify well-defined requirements, you establish fixed timelines, and you map out sequential activities.
Right.
You simply cannot alter the pricing module in the system until the revenue database itself is upgraded. Step B absolutely must follow Step A.
Which brings us to the crucial question of when you should actually deploy this approach. Because it clearly isn't for everything, right?
Definitely not.
Our sources reference project management experts Mark Quandrins and Annette Vendelbo, who offer some pretty brilliant filtering questions. The first one being, what is the degree of innovation?
That's a vital question. If you are a startup inventing a completely brand new piece of wearable technology where the hardware constraints and user requirements are volatile and changing every single afternoon.
A predictive approach is just going to suffocate your team.
Exactly. You would need an agile or adaptive methodology. But if you are deploying a software system that you have already successfully deployed in 500 other locations, and you are just rolling it out to the next 1,000.
Then a predictive methodology is your greatest asset.
100%.
They also suggest asking if there are safety or regulatory requirements, which, makes perfect sense. If you are building a commercial airplane, you really need all the aerodynamic safety testing planned out and completed before you start bolting wings onto the fuselage.
Yeah, that's not a place for trial and error.
Right. You don't want to just iterate a jet engine mid-flight to see how the customer feels about it.
Absolutely. The cost of failure really dictates the methodology. Vendelbo also recommends looking at the unknown unknowns. Like, has your organization executed a project like this before?
Meaning, do we have historical data?
Exactly. If you have access to past schedules, historical risk registers, established templates, if this project is essentially a recipe your team has cooked a dozen times before, you lean heavily into the predictive model to maximize efficiency.
I understand the theory, but, here's my immediate hurdle. Let's say you establish that you need a predictive approach. You are staring down that 2,000 hotel software rollout.
Okay.
How do you keep the project team from just drowning in the sheer volume of work? I mean, staring at a goal that massive has to be paralyzing.
Oh, it is. And that paralysis is exactly why the methodology relies on the visual backbone of the entire project, which is the WBS, or work breakdown structure.
Ah, the WBS. I spent some time with this in the source material, and it comes with some incredibly strict, almost quirky rules.
It really does. The foundational rule is the 100% rule. A work breakdown structure must contain 100% of the work defined by the project scope.
So no hidden tasks.
None. If a task or a deliverable is not explicitly listed in the WBS, it legally does not exist within the project. You just do not do it. But the rule that consistently frustrates new project managers is the naming convention.
Yes, the nouns.
Right. You must define the elements within the WBS using nouns and adjectives. You are strictly forbidden from using verbs.
Okay, I really want to dig into this because it feels so counterintuitive at first glance. A project is fundamentally about doing things. It's active.
Sure.
Why on earth am I banned from using verbs?
Because a WBS is relentlessly deliverable focused. It is not a process document. It is about what tangible thing you are creating, not how you are going to create it.
Interesting.
So instead of writing train the hotel staff, which is an ongoing verb phrase, you were forced to write staff training materials
Yeah.
and completed staff roster. By forcing you to use nouns, the methodology forces you to define the actual tangible output that proves the work is done.
Okay, let me try to put this into a day-to-day context to see if I have it right.
Right.
If I am renovating my house and I write paint the room on my to-do list, that's a verb. I might spend 10 hours painting, get tired, pat myself on the back, and call it a day. But the trim isn't done, the painter's tape is still stuck to the ceiling, and the drop cloths are everywhere. The verb paint just means I did the activity.
Exactly.
But if my WBS requires a noun and I write a fully painted, clean room, I literally cannot check that box until the tangible result exists. Verbs seem to hide incomplete work, whereas nouns demand actual results.
That is a phenomenal way to articulate it. Verbs allow for ambiguity. Nouns demand concrete evidence.
I do have to push back a little on the implementation of this, though.
Sure.
If we take a massive global project and decompose it into these microscopic, hyperspecific noun-based chunks, don't the people doing the work just get totally lost in the weeds? Doesn't the overarching mission just vanish into a sea of sticky notes?
You are hitting on the core tension of project planning. Vasco Rosina, a risk analyst who worked on the massive Panama Canal expansion, addresses this exact danger in our sources.
What does he say?
He notes there is a remarkably thin line between too much detail and too little. The WBS is a visual representation of the scope. It shows the hierarchical relationship of deliverables. But it is not, and this is critical, an instruction manual on how to do the job.
Oh, I see.
If you break a software rollout down so far that you are documenting every single mouse click a developer needs to make, you've destroyed the tool. You shift the team's focus from critical project milestones to trivial micromanagement.
So practically speaking, where do you stop decomposing the work?
You stop when you reach what is called the work package. That is the lowest, most granular level of the work breakdown structure. Now, Rosina points out a vital mechanism here. Every single work package must be assigned to one specific owner.
One person.
Just one. This is far more than just administrative delegation. It's a profound risk management strategy. It creates absolute accountability, totally eliminating the dreaded, I thought someone else was handling that syndrome.
Oh, we've all been there.
Right. And by defining the edges of someone's responsibility, it actually forces communication, preventing teams from working in isolated silos.
That structural clarity makes a lot of sense. But here is the next logical step. We have this beautiful list of nouns, these tangible deliverables. But a list of nouns doesn't build itself.
No,
You need materials, you need people, you need software licenses.
which introduces the vital sibling of the WBS, the RBS, or resource breakdown structure. Muhammad Ali Khawaja outlines a highly effective approach for building this. You don't just guess what you need.
Okay, so how do you do it?
You start top-down to establish broad categories for the entire project's labor, machinery, software facilities. Then you sit down with the subject matter experts on your team and build bottom-up to identify the exact granular specifications within those broad buckets.
So it's very similar to how you might plan a wedding or a major home renovation. You don't just say, I need stuff. You build an RBS by separating the broad categories, like labor versus materials. And then under labor, you specify you need one licensed electrician and 2 general carpenters. Under materials, you specify the exact square footage of lumber. You get granular.
Precisely. You quantify the exact specifications to ensure you aren't under-resourced when the work actually begins.
Okay, so we have our WBS mapping the physical scope and our RBS mapping the resources required to build it. But these are still just theoretical trees on a piece of paper.
Yeah, there's plans.
They don't mean anything until you map them onto a calendar and attach a bank account. And here's where it gets really interesting. Our sources explore what happens when you take these rigid predictive controls and apply them to the chaotic genius of historical master artists.
It is such a wonderful thought experiment because we culturally view these artists as completely untethered, driven purely by divine inspiration. But the reality of creating their masterpieces was fraught with brutal logistical and financial nightmares that modern project management could have easily solved.
Let's bring Da Vinci back in. As we mentioned at the top, it took him 16 years to paint the Mona Lisa. If I am the patron paying for that portrait, I am absolutely losing my mind.
And understandably so. If Leonardo had utilized a basic project management plan, he could have established a definitive timeline with clear, measurable milestones.
Like what?
Well, he could have allocated 6 months for the initial sketching phase, perhaps 10 years dedicated to the painstaking application of his famous sfumato layering technique, and a final 6 months for varnishing and curing.
Just having that schedule up front manages the patron's expectations.
Exactly. Furthermore, a formal risk management plan would have forced him to identify threats like material supply delays, patrons pulling his funding, or the literal paint drying too quickly. It would have allowed him to plan mitigations years in advance.
Then the sources look at Michelangelo painting the ceiling of the Sistine Chapel. That was a physically agonizing, mentally crushing endeavor that took 4 years of him mostly lying on his back.
For Michelangelo, implementing a simple Gantt chart would have been revolutionary. By visually mapping the sequence of tasks against a timeline, he could have mathematically optimized the construction and movement of his massive scaffolding. He could have sequenced the fresco application section by section, tying it to his work breakdown structure.
Rather than just winging it.
Right. Instead of marathon, unplanned work sessions that destroyed his health, he could have managed the staggering scale of the ceiling with predictable pacing.
And then there's Vincent van Gogh. The source material highlights his staggering output. I mean, he produced roughly 2,000 artworks in a single decade.
It's credible.
But his life was plagued by severe mental health struggles and total financial ruin.
Given the extreme volatility of his life, Van Gogh's ultimate tool would have been a risk register. He was operating in a high-risk, high-output environment.
So he needed a way to track that.
Yeah, if he had systematically documented his high-probability, high-impact risks, such as severe illness interrupting his painting schedule, running out of canvas and oil paints, or total financial collapse, he could have developed proactive response plans rather than reacting to constant crises.
It's an incredible mental image, Van Gogh sitting at a desk filling out a bureaucratic risk register. But the logic is undeniable. Maybe a mitigation plan would have been holding on to his steady job at the art auction house just a year longer to build a financial runway before diving entirely into painting.
Exactly.
But of all the artists mentioned, my absolute favorite example from the sources is Claude Monet.
Monet provides the perfect bridge to our next concept, specifically his work on the Water Lilies series.
Yes, because his work was entirely hostage to the environment. He was completely dependent on specific daily lighting conditions. Like, he had to capture the light exactly as it hit the pond at a very specific hour of the morning.
Which means his daily output was highly susceptible to weather delays, causing massive schedule and cost variances. In any predictive project, you cannot rely on gut feelings to know if you are succeeding. You need hard, quantifiable data to know if you are winning or losing on any given day.
And this is where we use performance metrics.
Exactly.
But if Monet is just standing in his garden staring at a cloudy sky, how does he actually quantify how badly he's failing? I mean, he can't just guess. He needs a hard number to know if he needs to buy cheaper paint to make up for lost time or if he needs to paint faster.
He finds that hard number using 4 core metrics. Let's walk through them using Monet's garden.
Okay.
The foundational metric is earned value, or EV. This is the monetary value of the work you have actually completed. Let's say Monet planned to paint half the pond by Tuesday, and he budgeted $100 for the paint in time to do it. That $100 is his planned value, or PV.
Okay, so planned value is what the schedule says he should have done by Tuesday.
Correct. But let's say it rained, and by Tuesday, he only finished a quarter of the pond. The value of that completed work is only $50. That $50 is his earned value.
Got it. Earned value is the credit he gets for what is actually on the canvas.
Exactly. Now we calculate the variances. First is cost variance, or CV. The formula is simply earned value minus actual cost. Let's say Monet earned his $50 of value, but because he was rushing, he used a massive amount of expensive imported blue paint, and it actually cost him $75.
Okay, so 50 minus 75.
Right. 50 minus 75 is negative 25.
So a negative cost variance means he is bleeding money. He is $25 over budget.
Yes. Next is schedule variance, or SV. This is earned value minus planned value. He earned $50 of value, but his plan said he should have earned 100 by Tuesday. 50 minus 100 is negative 50.
So again, a negative number is bad news. He is behind schedule by a quantifiable metric of $50 worth of work. Variance is just raw subtraction. It gives you a dollar amount of how far off the path you are.
It does. But raw numbers don't always tell the whole story, especially on a multi-million-dollar global rollout. Sometimes you want to see your performance as a ratio, a measure of your overall efficiency.
Oh,
That is where our indexes come into play, the Cost Performance Index, or CPI, and the Schedule Performance Index, SPI. Instead of subtracting, you divide. CPI is earned value divided by actual cost. SPI is earned value divided by planned value.
and the golden rule for these indexes is always the number one.
The number one is the holy grail of project management. If your index is exactly 1, you are perfectly on target. Your efficiency is 100%.
Nice.
If it is greater than 1, say your SPI is 1.2, you are performing exceptionally well. You are getting 20% more work done than planned. But if it drops below 1, say an SPI of 0.8, you are in serious trouble.
So Monet could have looked at his tracking sheet, realized his SPI was zero point 0.7 because he missed the optimal morning light 3 days in a row, and known instantly that he needed to adjust his process or ask his patrons for an extension. It turns a vague feeling of falling behind into a hard, actionable data point.
It completely removes emotion from the evaluation of progress.
Okay, but all of this theory brings up a massive reality check. We have a flawless work breakdown structure full of concrete nouns. We have a strict timeline. We have an RBS. We are tracking our SPI and CPI ratios like Monet on a mission. But, reality doesn't care about our spreadsheets.
It really doesn't.
No project exists in a vacuum. How does a rigidly fixed predictive plan actually survive contact with a chaotic real world?
It survives through a rigorous discipline called integration management. It is the art of continuously connecting the dots across all these different plans as the project evolves, dynamically balancing the constraints of the predictive triangle time, budget, and scope.
The source material has a brilliant story highlighting this from Masha Nime, an IT expert. Her team was assigned a very specific scope. They had to fix the software interoperability between 2 different video conferencing systems the company was using.
That was the rigid predictive requirement. But through the ongoing process of integration management, which involves constantly aligning the project with the actual strategic needs of the business, they uncovered a massive revelation.
Right. By talking to different departments to integrate the software, they realized the actual problem hurting the company wasn't that the software systems couldn't talk to each other. The real problem was exorbitant corporate travel costs.
Yeah, employees were flying across the country just to have meetings because they didn't trust the video systems.
So the entire goal of the project pivoted. Instead of fixing software bugs to make 2 systems talk, they zeroed in on driving the adoption of just one reliable system to eliminate the need for travel, saving the company a fortune.
Integration management is the connective tissue. It is what allows a project manager to see the macro business environment, ensuring the project remains aligned with the actual benefit the organization needs, rather than just blindly executing a technical plan that no longer serves a strategic purpose.
To make this integration concept super relatable, let's look at the party planning analogy from the sources. You're throwing a huge anniversary party. You have a schedule, a guest list, a budget. It's all mapped out. But then disaster strikes. The caterer cancels 3 hours before the party.
A classic high-impact project risk realized.
Integration management is the mechanism that ensures you don't just throw up your hands, declare the project a failure, and let your guests eat the decorative table centerpieces.
Exactly.
It's how you dynamically assess the impact across all areas. You look at your budget, you look at your timeline, and you immediately pivot to ordering 50 pizzas from the place down the street. You keep the different integrated parts of the project, the food supply, the timeline, the guest experience moving forward together despite the shock.
This raises an important question, though. Pivoting to pizza is a change in vendor. But what happens when the fundamental scope itself simply has to change?
Oh, yeah.
What if the client, or the regulatory environment, demands something entirely different halfway through execution?
Right. What if we are back at our baseline analogy? Like we are at the stove, we've started boiling our egg, we are 5 minutes in, and suddenly the client walks in and says, actually, I want an omelet.
In a purely predictive environment, changing the locked scope is a monumental event. You cannot just casually crack a half-boiled egg into a frying pan and scramble it. Changing the core requirement from a boiled egg to an omelet technically means the original project has failed, or at the very least has become obsolete.
But wait, that sounds like a bureaucratic nightmare. If my boss asks for what she thinks is a minor tweak to a deliverable, and I tell her, sorry, I have to formally declare this project obsolete, close it, and initiate a new one, I mean, I am going to get fired on the spot.
In the reality of a modern office, it certainly feels heavy-handed.
Hmm.
But the predictive methodology demands this rigidity for a very specific reason.
Which is,
Your budget, your resources, and your timeline were precisely calculated based on the original locked scope. If you change the scope, because making an omelet requires butter, a pan, a spatula, chopping vegetables, without recalculating the critical path of your schedule and requesting new funds, the project will inevitably bleed money or collapse entirely.
so what is the actual mechanism to handle the omelet request without everything catching fire?
You invoke a formal process governed by a Change Control Board, or CCB. This is a designated group of stakeholders with the authority to approve or deny scope changes. The project manager must submit a formal change request form.
Okay.
This document outlines exactly how the proposed change will impact the budget, the timeline, the work breakdown structure, and the performance measurement baseline.
You are basically forcing the client to see the cost of their new idea, and if the board approves the omelet,
Then the project manager formally closes out the boiling an egg project. You document the closure, release the boiling water resources, and start entirely from scratch. You initiate a brand new Making an Omelet project, complete with a newly approved scope, schedule, and budget.
that level of rigor is intense, but the sources provide a cautionary tale of what happens when you don't respect that process. Esteban Villegas shares a story about a major app development project. Halfway through coding, a sudden, massive security compliance requirement emerged from the client. The scope drastically changed.
And because the development team didn't respect the rigor of the predictive methodology they didn't rely on their existing plan to calculate the new critical path, and they didn't submit a formal change request for more time and money. They simply tried to absorb the massive new workload on the fly.
And the result was a total disaster. They missed their deadlines, their resources burned out, and they ultimately lost the trust of the client.
Yep.
It proves that a schedule isn't just a calendar on the wall. It's a mathematical tool you use to calculate the exact impact of reality colliding with your plan.
You're hitting on the core trade-off. The predictive approach offers very low flexibility, but it trades that flexibility for incredibly high certainty and rigorous control.
So what does this all mean for you? Whether you are mapping out a global software rollout across 2,000 hotels, trying to paint a canvas like Monet, or just trying to organize your chaotic weekend to finally get the garage cleans, a predictive framework is an incredibly powerful lens. By locking in your scope, using a WBS to break down the work into tangible nouns with assigned owners, and tracking your progress with hard metrics, you take overwhelming chaos and transform it into a predictable, manageable sequence of wins.
It is entirely about intentionality. It is about understanding the environment you're operating in and choosing the right structural tool to tame it.
And as we wrap up this deep dive into the source material, we want to leave you with one final, provocative thought to mull over. Let's go back to that omelet.
Ah, yes. The insidious scope creep of daily life.
Exactly. In our personal and professional lives, we are constantly, reflexively accepting tiny changes to our goals. We agree to do a little extra research here, to take on one more administrative task there, to stay an hour late without ever officially closing the original expectation or asking our bosses for more time or resources.
We constantly try to turn the boiling egg into an omelet while it is still sitting in the hot water.
Right. We absorb the variance internally, usually at the cost of our own well-being.
It's so true.
So ask yourself, if we treated these everyday scope creeps with the rigorous closure and restart of a true predictive project, if we actually stopped, submitted a mental change request form, and demanded the necessary time and resources for every new goal thrown our way, would we suddenly cure our own chronic burnout?
It is a fascinating question, and perhaps a necessary strategy to carry forward with you.
Definitely something to think about the next time you put a pot of water on the stove. Thank you for joining us on this deep dive. Keep questioning, keep planning, and keep exploring.